Hi, my name is Lance Matheson, and this is my presentation on composite hockey sticks. So to start, we'll go with our material systems. As seen for the materials, you can see that it is Textreme spread toe fabric, and that's actually going to be made out of graphite and manufactured by Oxeon AB, and that's actually a company of Mitsubishi. And then you have a 15K toe unicarbon tape, and there's actually small amounts of Kevlar and Nomex involved in that as well. For the pre-preg, so they use pre-preg, and it uses Elastec resin. And as far as that fiber orientation goes, each company does it differently, but I was able to find one that Bauer uses, which is a really common hockey brand, and the core cross section of that is a 30, 45, 30, 19, 0, and 30. And so there's a quote by the head engineer from Bauer that basically obviously states that more layers of 0 fiber increase linear stiffness, more layers of 45 fiber increase torsional stiffness, and more layers of 90 increase resistance to buckling. So moving on with more material systems, was able to find some stuff about the mold materials, and they used metals such as steel or iron. Didn't have exact types of metals, but they did mention steel and iron. As far as material cost goes, the companies really keep that type of stuff on lock just because they're competing with the other companies. So the amount of Kevlar, the amount of Nomex, and the amount of graphite and where they use it and how much that costs is really depends on what company you buy through. I was able to find out that Bauer sells their hockey sticks to the NHL for $185, and the Bauer does sponsor the NHL, so they pay wholesale and not retail prices. So at $135 or $185, and then the NHL pays for shipping. So I'm estimating at about $150 a stick, and that includes labor and as well as materials. And just for reference, it would cost about $300 to buy that same stick at retail. All right, so moving on to the manufacturing process, I was able to find 3 main methods that companies use to manufacture composite hockey sticks. So for method number 1 was a shaft-shaped mold that was wrapped in the composite material and then put inside a duplicate split mold. And then after that outer mold is closed, the composite material inside is compacted by the hydraulic press, and then boom, out comes a hockey stick. All right, the second method is very similar to the first one, except it uses vacuum pressure to force the composite material against the mold, just like we did in lab, and instead of the hydraulic press. And with the last method, method 3, it uses a bladder, and so what that does is the bladder is wrapped in composites, and then that is thrown into another mold, and the bladder then provides internal pressure and presses against the mold and forges it into the element shapes, which is seen in video too. So with all the methods completed, they're all thrown into an autoclave. I did find one company that did not use an autoclave and just let the composite sit overnight until it was hardened. And then with the finished sticks, all the post-mold operations include sanding, applying a clear coat, throw on some decals, and the final layer of clear coat. And a lot of recent hockey sticks have actually had grips on them. So it's like some sort of material that is kind of like an adhesive that allows your gloves to grip the stick a little better. So the final little piece of the manufacturing process is the quality control. So all of these are hand laid, and so a lot of it is in visual inspection, but also the companies do perform tests, stress strain tests on the sticks actively when they're making them, and they will take sticks off the line and do some tests on those as well. So I was able to find 2 really good videos on the manufacturing of composite hockey sticks from 2 different companies, and it kind of starts off with how they make their weaves all the way and finishes with their secondary operations at the end.
process here to actually produce a stick has been the same as it's been since 2000. Our composite materials are laid out, cut, and customized for each particular product or pattern.
It starts with bringing in rolls of material, which are then cut into kits, and these kits range everywhere from shaft kits to blade kits, and they're very specific all the way down to the types of construction and pattern that we were going to build. And from there, they're brought over to the wrapping area, and we create all of the preforms for the blades and the shafts. The blades use a foam core material, which the composite is wrapped around, and then that's placed into the mold. For our shafts, the composite material is wrapped around a metal mandrel, which creates very consistent walls. We use an oven process to cure the shafts, and then once they're extruded, everything's put together with the shaft and the blade. We also have a process where the blade and shaft are molded together at the same time for a true one-piece construction. And then to finish the stick, each decal is specifically laid out with a laser to make sure that we're very consistent in terms of the placement. And then the sticks have a nameplate placed on them as the last step, and then they're boxed up and shipped off to that player.
UT, Zero.
Oh, UD, yeah.
This is UT.
Yeah, that's what you use for the lower flex stick?
Yes.
Yeah, like the 20 flex. Yeah. So you put them in here?
Yes, that's that.
And then you cut this? Oh, I see. They're actually making a hockey stick right here.
Yeah.
Wow.
There's a couple things in those videos that could probably use a little more explanation. I know there's going to be a question about two-piece sticks and one-piece sticks. So to answer that right now, no one uses two-piece sticks anymore because they're not available. So they no longer manufacture two-piece sticks. They're all one-piece. And that company, Easton, actually went out of business, and they were pretty much the only ones that made two-piece sticks. The other thing is at the very end of that video, you could see some flex testing being done. All right, so production rates. In 2019, there were 66.2 million hockey sticks sold worldwide. One company, Bauer Hockey, which is a larger company, but just their hockey section, had 120 employees and made just under $32 million in hockey sales, which is quite a big amount for a composite sports. And then estimated manufacturing time. Like 3 to 4 hours of really manual labor and about 2 work days to complete one stick with the autoclave and the curing and the processing. All right, and finally some interesting thinking points. So a lot of people don't realize how much a hockey stick actually flexes. So seen on the right here, you can see how much just on a normal shot, how much that stick really goes. And there's different flexes, like I just said. So the higher the flex number, the higher the stiffness. So when they were testing it earlier, they were testing the flex to make sure that it was aligning with what they were saying they're aligning. A typical adult stick range of flex is between 75 and 110. So if you're trying to do different shots and you need different flexes for different positions, that's what you do. And there's also different flex kick points. So if you have low and mid kick points, and depending on your shot and how you shoot and where you like to shoot from depends on where you use your kick point. So all of that really depends on where you put certain materials. So you might have Kevlar in a different spot for a flex kick point that's mid versus the low kick point. And you might have different weaves in certain areas depending on what the stick is trying to do. But that's, again, all proprietary. And finally, hockey sticks are extremely light. They only weigh 390 grams, which is actually 10 grams lower than a 12-ounce soda, which is super crazy, and especially with how strong they are and how much force a hockey player has, and the fatigue life of a hockey stick of constantly shooting. But again, that goes into hockey players go through, professional players go through 10, 20, 30 sticks a year. And finally, here are my references. Thank you so much for watching.